Hi, today we're looking at killer Sudoku. This is going to be a 3-part video series. In this first video, we're going to have a look at the killer Sudoku grid and how it works, what the rules are, and we're going to look at a couple of techniques to get us started on solving a puzzle. And the video after that, we're going to look at the 45 rule and some more advanced techniques that are essential for solving killer Sudoku. And then in the third video, we're going to work through this puzzle from start to finish, using all of those techniques to solve the whole puzzle. So let's get started on this first one then. What is killer Sudoku? Well, it's very much like the original popular Sudoku puzzle. There's some things that are the same about the grid, and there are some differences. Now, this is a level 1 grid. We're using a puzzle from our Killer Sudoku challenge, which you can download for free. There's a link in the description if you want to follow along. We're still playing on a 9x9 grid, just like normal Sudoku. The grid, as with normal Sudoku again, is split into rows like this, and columns, and also 3x3 blocks. Some people call them regions. We're going to call them blocks. And just as with normal Sudoku, the objective is to fill each row and column and block with the digits from 1 to 9 once and only once. We can use all the valid Sudoku solving techniques. They all work just as well in killer Sudoku as they do in normal Sudokus. So X-wings and make it singles and hidden singles and all of those sorts of things, they all work in normal Sudoku. So if you haven't played Sudoku before and you need a refresher or an introduction, we've got an in-depth tutorial on the website, so it would be worth going through that because you do need to know normal Sudoku techniques. That said, there's lots of differences with killer Sudoku as well. And the first obvious difference is that we're not starting with any pre-filled clue numbers. On the regular Sudoku puzzle, you'll see some or many even in an easy puzzle of the cells have got numbers in already, giving you a starting place. In a killer Sudoku, you don't. Instead, we've got these very small numbers. We call these sum numbers or target numbers. And these numbers relate to these dotted areas, which we call cages. And these sum numbers tell you that the numbers within the cage add up to this target number. So in this cage here, for example, 16, we've got 2 cells, and whatever goes in those 2 cells, they must add up to a sum of 16. Here we've got a 3-cell cage with a target number of 6, so we're looking for 3 numbers that add up to 6. Cages are not restricted to single rows or columns. Here we've got a cage that splits across 2 rows. We've got cages that split across columns, and we've got cages that split across blocks as well. And in fact, we can have cages that split across block and a column and a row. One other thing to mention is that by convention, cages do not repeat digits within themselves. So if we take this 3-cell cage as an example, as I said, it's split across a column and a row and a block, but we would not repeat any digit within it. So if we had a 1 here, for example, we would not have a 1 here or here. Obviously, we couldn't have 2 1s like that because they would be repeating within this column, which isn't allowed. But here, in theory, you could repeat between these 2 cells because they're in different rows, columns and blocks, but they are in the same cage. So the convention for killer Sudoku, and our puzzles all follow the convention, is that you do not repeat digits within a cage. So those are the rules. That's what the grid looks like. We've seen that it's very similar to Sudoku in some ways and different in others. So where do we even begin? Because we don't have any clue numbers to get started with. Well, there's some specific techniques that work with killer Sudoku. We're going to look at 2 of those in this video. And the first technique we're going to look at is called limited sums. If we take any given cage, and remember a cage is a dotted area, then there are only a certain selection of digits that will fit into that cage. So, for example, if we take this 2-cell cage here, the 16 sum, we're looking for digits that add up to 16, when in fact, the only 2 digits from 1 to 9 that can add up to 16 are 7 and 9. So we know that the 2 digits that go in that cage are a 7 and 9. What we don't know is which digit goes into which cell in the cage. So what we're going to do is write in what we call candidate numbers. These are the same as in Sudoku. When you have narrowed down digits to a particular set of digits, you can write those in as small numbers, candidate numbers, and they can help you solve the puzzle later on, as we'll see. So we know that we've got in each of these 2 cells, one of them must be a 7 and one must be a 9. We don't know which is which, so we will write in 7 and 9 in both of those. And just a quick word on these candidate numbers. What we tend to do when we're writing them in is not only do we write them in very small because we're going to have to scrub them out later, because we know that they're not the definitive odds to the cell, we write them in a particular order. So let's write something up here. I write them in like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we always follow the same position, then it becomes very easy to see at a glance. Even if you can't read the numbers because you've written them in very small, you can see at a glance what the numbers are just by the fact that they're in that position, as they would be on a G-pad, for example. That's the convention I'm going to use in these videos because that's the way I solve these puzzles. Okay, so we've got our candidate numbers in this 16 page. How do they help? Well, they help because although we don't know which way around they go, we do know that we already have a 7 and a 9 accounted for in this row. So none of these other cells in this row can contain a 7 or a 9, and that's useful information. We can do something similar with this 3-cell 6 cage. And at this point, I'm going to introduce you to the Kidder Sudoku cheat sheet. We have one of these on the site, and there's one in the PDF to Kidder Sudoku Challenge as well. And there's one on the site that you can download as a PDF, or you can look at it online. The cheat sheet is a quick way of seeing all the different combinations for given cell configurations. Now, we call it a cheat sheet. Whether you think it's cheating or not, I mean, that's up to you. I think of it as a shortcut. It just saves a bit of memorization or working things out, having to always work out what goes where. So we had the 16 cage, that was a 2-cell cage. If we look on the cheat sheets, you can see here on the 2-cell cage combination that the only possible digits that can go without are 7 and 9. That's why that is highlighted, because it's a single combination cage. If we look across on the 3-cell cage combinations, because we've put our 3-cell 6 cage, that's the first one up there, we can see that the only combination of digits that can go in there are 1, 2, and 3. And again, we don't know what goes where, but we do know that that's the only combination. So I'm going to write those in as small candidate numbers. And again, this is useful information because now we know we cannot put a 1, 2, or a 3 anywhere else in these cells because they have to go somewhere in here. If we move along this row, because we've already accounted for potentially for our cells here, we're going to look at the next cage along, which is contained entirely within the row, and that is this 2-cell 9 cage. If we look at our 2-cell combinations on the cheat sheet, we can see that there are 4 possible combinations there. We could have a 1 and an 8, a 2 and a 7, a 3 and a 6, or a 4 and a 5. In theory, which sounds like a lot of digits to write in as candidate numbers, but actually we can discount most of those because we can't put a 1, 8 in there because we've already got 1 somewhere in this cage, so that can't be a valid combination. Similarly, it can't be a 2 and a 7 because, well, we got a 2 in here and we got a 7 in here, so that's not a valid combination. What about 3 and 6? Well, again, we've got a 3 somewhere in here, so that can't be a valid combination. So in fact, the only combination that's left that could possibly go into this 2, 7, 9 cage is a 4 and a 5. So we'll write those in as candidate numbers using our convention, like so. We haven't solved any cells yet, but we've filled in a lot of candidate numbers, given ourselves some useful information, and we've only got 2 cells now in this row that are unaccounted for. This one here and this one here. But if we look at the candidate numbers we've already got, we got a 1, 2, 3, 4, 5. We don't have a 6, we've got a 7, we don't have an 8, and we've got a 9. So we know that these 2 cells must contain a 6 and an 8 between them. So we can write those in as candidate numbers as well. We've done that just by inference from what's remaining in that row. And this is where things get interesting. If we look at this 2-cell cage with a target of 12, and we look at our cheat sheet, we know we have to have either a 6 or an 8 in our cage. And the only combination of the 3 available that fits into that is a 4 and an 8. We know we cannot put a 4 down in this cell because we've got a 4 here, which would mean 2 4s in the same row. So we can determine that we must put, I'm going to write these in blue so we can see how 4 up here and our 8 must go down here. So we've just solved 2 cells. And because we've solved our 8 in here, we know that we can't have another 8 down here. We can cross out our 8 and we can look at this 15 cage now, 2 cells with a target of 15. See that the only combination that can go in there that makes use of the 6 that we know must be in here because we've got rid of the 8 is 6 and 9. Now we can write those in as well. We know we've got the 6 down here because that's the only candidate left. So we've got a 6 here and a 9 here. So even though we started this grid with no clue numbers whatsoever, just by working out the possible combinations of numbers that could go into each of these cells, we managed to solve 4 cells completely. And we got something else on the cheat sheet that's very useful. And to demonstrate what that is, we're going to look at this 5-cell cage out clear with a target of 17. If we look on our cheat sheet at 5-cell combinations and 17, there are 2 combinations of digits that could go in there, 1, 2, 3, 4, 7 and 1, 2, 3, 5, 6. Something you may notice about those 2 combinations is that both of them contain the digits 1, 2 and 3. And those are what we would call required digits, so we can determine that although we don't know which combination numbers go in there, somewhere in that cage we must have a 1, a 2 and a 3. So they are candidate numbers for that cage. Now, rather than have to work through all possible combinations like that to see required digits, we keep those required digits on the last page of our cheat sheet, as you can see here. So we know that if we come across any, for example, 3-cell cages with a target of 8, then they have to include a 1. A 4-cell cage with a target of 13 also has to include a 1, and so on. So looking at required digits early on in the puzzle is a quick way to find candidate numbers, because you determine that they must go somewhere into that cage. Now, one other thing I want to show you before we finish this video is that also on our website we have Killer Sudoku Calculator. This is what it looks like, and it's an alternative to using the cheat sheet. And what you can do, for example, is pick the number of cells in a cage. So if we take that 17 cage, for example, bump that up to 5 cells, we pick our target number, which is 17, and that tells us the possible candidate numbers, the 2 combinations that we mentioned, and if there are any required digits. We can see there are 1, 2 and 3. Calculator has some other tricks up its sleeve. We can include and exclude certain digits, and that will come in handy later on when we're looking at solving the whole puzzle. The next video in this series, we're going to look at a really powerful set of techniques, all based around what we call the 45 rule, and then we'll go on to solve the puzzle from start to finish. So until then, if you want to have a go at this yourself, you can get this exact puzzle by downloading our Killer Sudoku challenge. It's free. There's a link in the description. There's 7 puzzles in that pack of increasing difficulty, and there's some tips on there, the entire cheat sheet, and of course all the solutions.